Hello students, I am Nilanjana Senial. Welcome you all to my channel NS Online Math Classes. Our today's topic is factorizing cubic polynomials. This is method 2. We have already had one video session on factorizing cubic polynomials where we have learned how to factorize a given cubic polynomial or cubic expression by equating the coefficients of equal powers of x from both the sides of an equation. Now in this method we will be using the synthetic division. I have written using the synthetic division, but because I have explained, I have already made a video on synthetic division method, but you may use the algebraic long division method as well. I'll be making video sessions on algebraic long division method. I'll be having 2 video sessions on algebraic long division method. But till now, since I have not made any video on that method, I have written using synthetic division, but you may use the algebraic long division method as well in place of synthetic division. Okay. So let us first of all look at the cubic expression that has been given to us, which has to be factorized, and let us start our today's session without any further delay. Factorize x to the power of 3 plus 13x to the power of 2 plus 32x plus 20. Okay, now you see every power of x is present in the given cubic polynomial starting from the highest power, that is 3. Obviously, it has to be 3 because it is a cubic polynomial. But in case you have some missing term, in case you do not have all powers of x present or all powers of the variable present in the given expression, then you have to take the coefficients of those powers of the variable as 0, because you need every coefficient, every power of the variable is needed along with their coefficients. So if you do not have any power of the variable in the given expression, take its coefficient to be equal to 0 because you will be needing that. Okay. So now let us go to the rules part. Take small numbers like 0, plus minus half, plus minus 1, plus minus 2, or at the most plus minus 3. One by one as value of x and find the value of for which the cubic expression becomes equal to 0. Now, I myself don't go for plus minus half. First of all, I start with 0 and then move on to the plus minus 1. Okay, you may take plus minus half after 0, but first of all, I deal with the integers, and if I cannot find any number which is giving the expression value as 0, then only I move to this fraction part. Okay, so I'll be doing exactly the same thing over here. I'll be starting with x equals 0. When x equal to 0, what is the value of the expression? It is 0 plus 0 plus 0 plus 20. So the expression value is equal to 20, not equal to 0. So x equal to 0 cannot be our desired number. We are searching for a number which, when substituted for x in the given expression, will make the expression value equal to 0. Now we can take the next number as plus 1, but over here you see every term is a positive term. So if you substitute 1 in place of x, you will never be getting a value of 0. Even then, I'm just showing you what will be the sum total if you take x equals 1. It is 1 from the first term, 13 from the second term. 1 plus 13 is 14, 14 plus 32, 14 plus 2 is 16, 16 plus 30 is 46, plus 20 is 66. It is not equal to 0. So when you see every term is a positive term, you can just leave the positive numbers because they will never be giving you a 0. So I have tried minus 1. When x equal to minus 1, what happens? Minus 1 to the power of 3 is minus 1. And minus 1 whole square is a plus 1. So it is 13 minus 1, which is giving us 12. This is 32 times minus 1, so it is minus 32. So minus 32 plus 12 is minus 20, and plus 20, the value is 0. So when x equal to minus 1, the expression value is equal to 0. So we have got the number which, when substituted in place of x in the expression, the value of the expression becomes equal to 0. So x minus that number is a linear factor of the expression, of the given cubic expression. So x minus the number is minus 1. So x minus minus 1 or x plus 1 is a linear factor of this cubic expression. We have found the linear factor, so we will be finding the quadratic factor, because the linear factor when multiplied with a quadratic factor will be giving us this x cube. Okay, because the quadratic factor will be having a term containing x squared. X when multiplied with x squared will be giving us x cubed. Okay, so the other factor will be a quadratic factor. Now we have to get that quadratic factor. Okay, so how to find that quadratic factor? We come to the rule 2. Perform the synthetic division or the algebraic long divisions. You may use any of them with the linear factor as the divisor and the cubic expression as the dividend to get the quadratic factor, which is the quotient of the division. Whatever will be the quotient of the division will be the quadratic factor. Okay, so now we will be performing synthetic division in our today's session to get the quadratic factor. And in case you do not know the synthetic division method, I would definitely be asking you to watch my video on the synthetic division method of dividing polynomials. Okay, so first of all, what do? We take the coefficients of every power of x and we write them in a line. 1x cubed, so it is 1. 13x squared, it is 13. If you have any negative number, you have to take the negative sign along with the number. 32x, it is 32, and 20, so it is 20. Okay, we have written every coefficient of every power of x. That is why I have said, in case you have any missing power, you have to take the coefficient as 0 and you have to write that over here. You have to write all the coefficients of all the powers of x starting from the highest power. Okay. Next, what do? We have to write this part, this number over here. It is not x plus 1. It should be x minus some number. X minus the number is the linear factor. And what is the number? It is minus 1. So we have to write minus 1 over here. Okay. Next, what do? We bring down, this is line number 1, we bring down the first term, first number of line number 1 in line 3. As it is, whatever is the number, we bring down that number. Next, we multiply minus 1 with this number. It is minus 1 is the product. Minus 1 times 1 is minus 1, which we write over here beneath 13. And we add these two numbers. 13 minus 1 is 12. Again, we multiply 12 with this minus 1. Product is minus 12, which we write over here. And we add these two. 32 minus 12 is 20. Minus 1 times 20 is minus 20, which we write below minus plus 20. And adding 20 and minus 20, we get a 0. And this last number is the remainder of the division, which is equal to 0 in our case. And all these, the other numbers of this line 3, are the coefficients of the quotient. The quotient will be a quadratic expression. This one will be the coefficient of x squared. 12 will be the coefficient of x and 20 will be the constant term. It will always be in the descending powers of x. So the quotient is x squared plus 12x plus 20. So now we can write this is the given cubic polynomial x cube plus 13x squared plus 32x plus 20. This can be written as x plus 1 because x minus minus 1 is x plus 1 times this quadratic factor, this one, x squared plus 12x plus 20. Okay. And finally, factorize the quadratic factor if possible. In this case, we can factorize this quadratic expression using the middle term splitting method. I have factorized this part, and the total factorized form of this given cubic polynomial is x plus 1 times x plus 2 times x plus 10. X plus 2 times x plus 10 is the factorized form of this quadratic part, x squared plus 12x plus 20. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.